today's lecture, we'll continue our discussion on cloud services. In the previous lecture, we learned about cloud reference model, which included 7 layers: infrastructure layer, hardware layer, and virtualization layer. Together, these 3 bottom layers were called infrastructure as a service layers. On top of these, we had 3 more layers: platform and middleware layer, service management layer, and the application layer. Along with these 6 layers, we also had a security layer. Then we went on to see compute services, and we saw one compute service which is provided by Amazon, that is Amazon Elastic Compute Cloud, EC2, in detail. Today we'll continue this discussion, and we'll see what are the storage services. Cloud storage services allow storage and retrieval of any amount of data at any time from anywhere on the web. And most of these services are organized data into buckets or containers. Buckets are nothing but virtual containers which contain the objects. Scalability. So cloud storage service, they provide high capacity and scalability. Objects up to several terabytes in size can be uploaded, and multiple buckets or containers can be created on the cloud storages. So scalability is one of the major features because of which the users opt for storage services on the cloud. Because if a user wants to store a huge amount of data, and tomorrow if that data grows or it shrinks, the cloud storage is able to accommodate that variation in the storage. And the user is of course charged as per use. The amount of storage they will be using, they will be charged based on that. Next advantage or feature of storage services: replication. So it says that when an object, or that is the data, is uploaded in the cloud, it is replicated at multiple facilities and or on multiple devices within each facility. So this replication is done to provide reliability to the user. The data should not be lost. So because of that, redundant copies of the data are stored at multiple locations or in multiple devices within each facility. Apart from providing reliability, this also ensures availability. So if a user's data is stored in one of the data centers, which is, let's say, located in one part of the world, then in some other part of the world also that data will be replicated. So this not only provides the reliability, but now user, wherever he is, if he accesses the data, he'll obtain that data from whichever data center he's closer to. Access policy. So cloud storage service provides several security features such as access control list, ACLs, bucket or container level policies, etc. So what are these access control lists? They can be used to selectively grant access permission on the individual objects. These bucket and container level policies, they define to allow or deny permission across some or all the objects within a single bucket or container. That means there can be certain object which is the data, they can be they can deny or allow the permission to a specific or a group of user to access a particular or all of the data. So this depends on the user requirement or how sensitive the data is. Encryption. Cloud storage services provide service-side encryption option to encrypt all the data stored in cloud security. So this is to ensure the data security while it is stored in the servers or the data center. Consistency. Strong data consistency is provided for all uploads and delete operation. Therefore, any object that is uploaded can be immediately downloaded after the upload is complete. So if the data is updated in one of the locations, then immediately At the same time, it will be updated in all other locations wherever a copy of the data has been stored. This is called as a strong data consistency. So that means if the user has modified the data in one of the locations, the same modification will reflect in all other location immediately. So as soon as that modification is done, if that data is downloaded from some other location, it will reflect those modifications. So now let us look at the storage service which is provided by Amazon. It is called as Amazon Simple Storage Service, or in short Amazon S3. So S3 is an online cloud-based data storage infrastructure for storing and retrieving any amount of data. So it provides highly reliable. We have seen what reliability means. It means replicating the data at multiple locations. Scalable, scalable because it should be the provider should be able to scale the amount of storage given to the user as per their data. It is fast, fully redundant, and affordable storage infrastructure. So data stored on S3 is organized in form of buckets. That is, the user must create a bucket before it can store data on S3. So basically, let us see the steps which are followed to upload files on bucket. So S3 console provides a simple wizard for creating new bucket and uploading file. Any kind of file can be uploaded to S3. While uploading a file, the user can specify the redundancy and encryption options and access permission. So user can define this while uploading, while creating the bucket. So Amazon S3 has two core components. First is buckets and second is the objects. So bucket represents the virtual container in which the objects are stored. And what is the object? Object represents the content that is actually stored. Objects can also be enriched with metadata. Metadata is the data which describes other data. So objects can also be enriched with metadata that can be used to tag the stored content with additional information. Then S3 has been designed to provide a simple storage service that is accessible through a representational state transfer interface. So this interface is called REST interface. So access to S3 is provided with RESTful web service. So these express all the operations that can be performed on the storage in form of HTTP request. So RESTful interface, or this RESTful web services, so it is not a standard. So RESTful state transfer interface is not a standard. In fact, it uses many standards in HTTP command, and it is a very lightweight and has very less complexity. So using a RESTful interface, any server can be accessed. There is no need to, there is no requirement of any specific mechanism to follow, and this is its biggest strength. So since it uses HTTP request, and HTTP requests are get, put, delete, head, and post. Put or post requests are used to add new content to the store, that is the bucket. Get and head requests are used to retrieve the content and information from the bucket, and delete requests are used to remove elements or information attached to the buckets. And, the key concepts of S3 are the storage is organized in a two-level hierarchy. So S3 organizes its storage space into buckets that cannot be further partitioned. So this means that it is not possible to create directories or any other kind of physical grouping for objects stored in the bucket. However, there are few limitations in naming objects, and but user can stimulate directories and create logical groupings. Second, stored objects cannot be manipulated like standard files. So S3 has been designed to essentially provide storage for objects that will not change over time. So it does not allow renaming, modifying, or relocating an object. So once an object has been added to a bucket, its content and position is immutable. Immutable means it cannot be changed, and the only way to change is to remove the object from the store and to add it again. So let us say I have a bucket and I have added some data to it. I have added a file to it with a certain name. Now, once I have added that file into a particular bucket, I cannot, and I want to, let's say, rewrite something in that file or modify it. Maybe I want to rename it. I cannot do that. The only option is I'll have to retrieve it from the bucket, modify that file again, and then again store it in the bucket. So stored objects cannot be manipulated like standard files. Next key concept of Amazon S3 is that content is not immediately available to the users. So we saw that storage services, though, should provide a strong consistency, or that is what is desirable. Amazon S3 does not provide strong consistency to the users. In fact, it provides eventual consistency to the users. That is, the main design goal of S3 is to provide an eventual consistent data store. Now, what is an eventually consistent data store? So eventually consistence means that if the data is stored in multiple locations and it is updated in one of the locations, then the data which is stored in other locations will be updated eventually. That is, updation will be propagated, but not immediately. So there is no assurance that all the copies of the data are updated simultaneously. So this is because Amazon's S3, it is a large distributed storage facility, because of which the changes are not immediately reflected. So for instance, S3 uses replication to provide redundancy and efficiently serve objects across the globe. So this practice introduces latency when adding objects to the store, especially large ones which are not available instantly across the entire globe. So this says that S3 uses replication to provide redundancy. It will obviously replicate the data. So if it has one data center which is in US, and let's say it has another data center which is in Australia. So if the same copy of data which is stored in US is replicated in Australia, and let's say user modifies the data which is in the US data center, then it will not immediately reflect in the those modifications will not reflect in the data center which is in Australia. It will take some time because obviously there will be propagation delay and this change is not immediately reflected. So during that time, if another user downloads the same data from Australia data center, he'll get the stale data. He'll not receive those modifications. Fourth is requests will occasionally fail. So Amazon S3 does not guarantee 100% availability. So and the last key concept is that requests will occasionally fail. Now, due to large distributed infrastructure being managed, a request for object may occasionally fail. Under certain condition, S3 can decide to drop a request by returning an internal server error. And these requests which are dropped, the small failure rate is acceptable to S3. So it does not ensure that 100% of the requests which are coming will be served. In fact, it is expected to have a small failure rate during day-to-day operation, which is not generally identified as a persistent failure. So it is expected that it will not handle 100% of the requests which are coming. So we saw the four key concepts of Amazon S3. So that is, first is the storage is organized in a two-level hierarchy. That means it stores the contents into objects into buckets. So why it is called two-level hierarchy? That means whenever user wants a data, it has to specify, let us say a file, it has to specify name of the file and the name of the bucket in which it is stored. So that is why two-level. Then the second concept was that the stored objects, they cannot be manipulated. Third is that it provides eventual consistency of data stored, and the fourth one is that a small failure rate is absolutely acceptable in this kind of service, Amazon S3. That is, requests will not 100% be honored. So let us see that what are buckets. So we'll see some concepts related to bucket. We'll see what a bucket is, then what is an object, and what is a key. So a bucket is a container of objects. It can be thought of a virtual drive hosted on S3 distributed storage, which provides user with a flat store to which they can add objects. So basically, it's a virtual drive. So buckets are top level elements of S3 storage architecture, and they do not support nesting. So what do we mean by this? That means we can create a bucket, but we cannot create sub buckets within the same buckets. So any kind of division of that bucket is physical division of that bucket is not possible. A bucket is located in a specific geographical location and is eventually replicated for fault tolerance and better content distribution. And this geographical location where the bucket is stored, user can choose that in which geographical location the user wishes to store the data. That is, user can select the location at which to create the bucket, which is by default are created in Amazon's US data center. That is, user can select the location at which to create the buckets, which by default are created in Amazon's US data center. So once the bucket is created, all the objects that belong to the bucket will be stored in the same availability zone of the bucket. And how the user creates a bucket by sending a put request to this link with the name of the bucket, and if they want to specify the availability zone and the additional information about the preferred location. So it uses all HTTP commands. So it will use put request will create a bucket. Then the contents of the bucket can be listed by sending a get request specifying the name of the bucket. Once created, the bucket cannot be renamed or relocated. So if the user wants to relocate the bucket, it will have to delete, the user will have to delete the bucket and create another bucket at the new location. Neither the bucket can be renamed. Even if the user wants to rename the bucket, they have to delete this bucket and create a new bucket and give it a new name. So that means if necessary to do so, the bucket must be deleted and recreated. And the deletion of the bucket will be performed by delete command, which is successful if and only if bucket is empty. If there are some objects which are stored in the bucket, then it cannot be deleted. So what are objects? Objects are the fundamental entities stored in Amazon S3. Object consists of object data and metadata. That is the data, and metadata is the data which has some other information about this data. The data portion is opaque to Amazon S3. So Amazon S3 can only access the metadata. The metadata is the set name value pair that describes the object. So metadata, so these include some default metadata such as data last modified and standard HTTP metadata, for example, content and the type. So whatever the content is stored and what type is stored, so type is describing the content. So these are some default metadatas. One can also specify custom metadata at the time, for example, the time at which the object is stored or anything else which depends on the user's requirement. So an object is uniquely identified within a bucket by a key and a version ID. If you want to know more about the objects and the keys, you can see this heading, keys using versioning, under Amazon S3 tab. So now let us see that what are keys. So key is a unique identifier for an object within a bucket. Every object in a bucket has exactly one key. The combination of bucket, key and version ID uniquely identifies each object. So basically it is an addressing method. So how to obtain a particular object which is stored in a bucket, you need the version ID needs to be known, the key and the bucket, the name of the bucket. So every object in Amazon S3 can be uniquely addressed through combination of web service endpoints, bucket name, key and optionally a version. So if you look at this URL, in this example, this doc is the name of the bucket. This bucket is obviously stored in Amazon s3.amazonaws.com, and this after slash this 2006-03-01 slash Amazon s3.wsdl is the key. Okay, so we have understood Amazon's S3 storage service. We have seen its key features. We have also seen that how the objects are stored and retrieved from the bucket. Now let us look at another storage service which is called Amazon Elastic Block Store. So Amazon Elastic Block Store allows AWS user to provide EC2 instances with persistent storage in form of volumes that can be mounted at the instance startup. So basically Amazon's Elastic Block Store is designed to use with Amazon Elastic Compute Cloud. They work similar to a hard drive. So basically a block store volume works similar to a hard drive. The user can store any type of file on it and even install the whole operating system on it. So basically it is whenever an EC2 virtual machine or an instance comes up, it is a form of persistent storage. So basically this EBS provides a raw block level storage that is attached with Amazon EC2 instances or virtual machine. Next is they accommodate up to 1 TB of space and are accessed through a block device interface. So block device interface, so that means any block device, for example this electronic block store. So this any block device first has to be attached to a particular EC2 instance, thus allowing the user to format them and use them according to the need for any instance they are connected to. So raw storage, file system or any other way they want to use it. The content of EBS volume survives the instance life cycle and is persisted into S3. So as long as the virtual machine is existing and is allocated to a particular user, so this block storage will have that data, will contain that entire files data, and once the virtual machine goes down, it will be stored in S3 service of Amazon. EBS volume can be cloned, used as boot partitioned, and constitute durable storage since they rely on S3 and it is possible to take incremental snapshot of their content. Clone means they can be replicated, they can also be used as boot partitions. Basically because they rely on S3 and they are stored continuously in S3, so it is also possible to take their incremental snapshot and store it in S3. So the EBS normally resides within the same availability zone of the EC2 instance that will use them to maximize the input-output performance. So it will not happen that the virtual machine is in some other geographical location and availability zone, and then the EBS, the hard drive basically. EBS acts as a hard drive. What hard drive acts for a laptop or a desktop, EBS acts for a EC2 instance. So they are within the same availability zone. The expense related to the volume comprises the cost generated by the amount of storage occupied in S3 and the number of input output requests performed against the volume. So, and how the billing model is that it depends on two factors: the amount of storage which is occupied in S3, and also the number of times the input output request has been performed against the EBS volume. So in this lecture, we saw storage services, we saw what are storage services, and then we have seen two services, which is Amazon S3 service and Amazon Elastic Block Store in detail. We'll continue with more services, more cloud services in the next lecture. Thank you.